Hi, I'm Roshni Asokan. Good evening to Madam Rabita. Today I'll be explaining about Culvert, which is one of the subtopic of MSMA. This is my presentation. Okay, regarding the introduction, a culvert is a relative short length of a conduit used to transport stormwater through an embankment. A culvert acts as an enclosed channel that serves as a continuation for an open channel through the embankment. However, flow through culverts depends on entrance geometry and flow depth at the downstream end. Consequently, flow computation for culverts are more complex than open channel flow analysis associated with pipes or drains. Culverts are typically designed to pass the designed discharge without overtopping the embankment or cause extensive ponding at the upstream end. Next, about the component. There are four types of inlet entries for culvert. First is the projecting barrel. Next is the cast in place concrete head wall and wing wall, and metered to the slope precast end section. These are the picture diagram, imagination of the picture of the type of inlet entrance. Okay, regarding the component, major component of a culvert includes the barrel and treatments such as head wall, end walls, and wing walls, outlet protection, inlet improvement, and debris control structures. And treatments such as head walls and wing walls protect the embankment from erosion, serves as a retaining walls to stabilize the bank and add weight to the counter on any buoyancy effects. Ideally, the culvert's center line should follow the line and grade of natural channel. In many cases, this cannot be done, and skewing head walls and wing walls helps accommodate the natural stream's alignment to the culvert alignment. Debris barriers are sometimes constructed on upstream and to prevent materials from entering and clogging the culvert. The barriers are placed far enough away from the entrance so that accumulated debris clog does not clog the entrance. At the inlet and outlet end of the culvert, and walls and wing walls serves as erosion protection for the embankment and inhibit piping along the culvert's outside surface. Downstream wing walls provide a smooth transition between the culvert and the nature stream's banks. Next, application. There are a few types of application. First of all, we will go through the shapes. Okay, the shapes we have four types: round, arc, low profile arc, and a box. Round shape is commonly used. We can see, for example, in this shape, it's obviously the round shape. Arc is for low clearance, large waterway opening and aesthetic. Low wide, and for low profile is for low wide with waterway enclosures and aesthetic. Box is for low wide waterway enclosures. Okay, these shapes or this application of shapes into culvert is selection. It depends on the construction limitation, embankment height, environmental issues, hydraulic performance, and obviously cost. The most commonly used culvert materials are corrugated steel, corrugated aluminium, and precast or cast-in-place concrete. Factors such as corrosion, abrasion, and structural strength determines the selection of the material. In case, in some cases where the culvert is located highly visible amenity area, selection of the shape and material may be based on an aesthetic as well as functional consideration. Next, hydraulic fundamental. There are two types of hydraulic fundamental, which is flow condition and type of flow control. We will go for the flow condition first of all. Okay, this is about a culvert barrel may flow full over of its length or partially full. Full flow in a culvert barrel is rare. Generally, at least part of the barrel flows partially full. A water phase profile calculation is the only way to accurately determine how much of the barrel flows full. There are two types: full flow of pressure flow, that's what I mentioned before, and partially full or open channel, we can call as open channel flow. Okay, for the full flow pressure, one condition where which can create pressure flow in a culvert is the back pressure caused by the high downstream water surface elevation. A high upstream water surface elevation may also produce full flow. It is therefore, regardless of the cause, the capacity of a culvert is affected by the upstream and downstream condition and by the hydraulic characteristic of the culvert itself. Partially full and open channel flow. The appropriate, we call it as an open channel flow regimes, namely subcritical, critical, and supercritical. It must be determined or accomplished by evaluating the dimensionless Freud number, which is we have learned FR. FR more than one, the flow is supercritical. It is FR less than one, it is subcritical, and FR equals to one is critical. So we can identify by that. Next, type of the this is the second fundamental type of flow control. Same here, we have two types of flow control: inlet control and outlet control. Inlet control occurs when the culvert barrel is capable of conveying more flow than the inlet will accept. The control section of a culvert operating under inlet control is located just inside the entrance. Critical depth occurs at or near the location, and the flow regime immediately downstream the supercritical. The upstream water surface elevation and the inlet geometry represent the major flow control. The inlet geometry includes the barrel shape, cross-section area, and inlet edge. Okay, goes to outlet control. It occurs when the culvert barrel is not capable, as for just now, inlet is capable of conveying, and for outlet, it is not capable of conveying as much flow as the inlet opening will accept. The control section for outlet control flow in culvert is located at the barrel exit or further downstream. Either supercritical or pressure flow exists in the culvert barrel under this condition. All the geometric and hydraulic characteristics of the culvert plays a role in determining its capacity. This characteristic includes all of the factors governing inlet control, water surface elevation at the outlet, the slope, the length, and the hydraulic roughness of the culvert barrel itself. Next, design consideration. We have three types, which is head water, multiple cell, and culvert in flat terrain. Okay. Uh, Head water is the water surface in the upstream of the culvert. Available headwater may be limited by the height of surrounding ground or the elevation at which the road formation cuts through the HEL. Most economical culvert is one which utilizes all of the available headwater to pass the design discharge. However, it is not always possible to utilize all the available headwater due to constraints that limit to upstream water level. The following factors should be considered in selection of the design of headwater. First is the limits on the backwater not to cause inundation of the properties upstream, the outlet velocity, and the potential scores. Next, multiple cells. The culvert shape selected will best fit the waterway of channel or stream. In narrow deep channel, a small number of large diameter pipes or box culverts are usually appropriate. In flat areas of no well defined waterway. The flood may be large in volume but shallow depth. A number of separate culverts spreads over the width of the flooded area may be appropriate. Special consideration should be given to the multiple cell culverts where the approach flow is high of velocity. Particularly, it is called supercritical. Next is the culvert in flat terrain. In flat terrain, drainage channels are often not well defined. Multiple culverts can be considered to have common headwater elevation. It is also necessary to construct level levee banks to achieve the design headwater at the culvert location, provide no danger of increasing flooding of upstream properties. The approval of the local drainage authority must be obtained prior to the construction of levee bank. Next, this is the design procedure. First of all, we're gonna assemble site data. That is the crucial one. Next, we're gonna determine design flood discharge. And then we're gonna commence summarizing data on design form. Select culvert. Determine it is inlet control, headwater depth, and then determine the depth HO. Determine the outlet control headwater depth at the inlet HWO. Determine the controlling headwater HWC, and then we're going to calculate outlet velocity VO, and then we're going to review the result, which is we're going to revisit back, and then we're going to improve the design if we have any kind of corrections. Next, the flow velocity. First of all, we have inlet control, and then we go to outlet control and erosion of conduit, score of inlet and outlet, and siltation. This is the flow of velocity. Alright, that's all from me regarding the culvert. It is one of the subtopic of MASMA. So that's all. Thank you so much. Thank you, madam.